Hi everybody, my name is Jewel Mendiola, and this is my interactive advanced concept presentation where we'll be making some elephant toothpaste. So here I'm just showing my hydrogen peroxide, and then I'm showing that this is a 3% hydrogen peroxide. I have two bottles here because I was going to use the first smaller bottle and wasn't sure if I was going to have enough. And then I'm just showing the Dawn Platinum dish soap that we'll be adding to hydrogen peroxide. And then finally our Fleischmann's yeast. Those are all the main components to this reaction. Well, really it's just the hydrogen peroxide and yeast, but then we've got the dish soap, and then we've got the food coloring, all more for the aesthetics. And then I've got my mason jar, which I'm going to be using as my container. A note on the hydrogen peroxide, since I'm using 3%, we'll have a slightly less exothermic reaction, and I was able to feel this, but I was still able to feel the heat, so I wasn't able to find 10% or 30%, but the reaction still occurred. So here I'm adding roughly about half a cup, and then I'm taking that and adding it to our mason jar. And then I'll be adding some dish soap to our hydrogen peroxide. What this is going to do is going to help create that foam by adding more surface tension to our liquid, because when hydrogen peroxide is going to react with our yeast, which I'll talk more about it, but oxygen gas is actually released, and since it wants to escape our liquid, with that dish soap, it's actually adding some increased surface tension and preventing that oxygen gas from releasing, and thus creating the foaming that is most notable about our elephant toothpaste. So here, just for the aesthetics, as I said, I'm adding some food coloring. I think that's like red and green and blue, and I was adding it along the rim because I saw online that if you do that, it's supposed to give that striped toothpaste effect. Ended up not really working out. It kind of just turned like a light green, as we'll be able to see in a minute, but nonetheless, we tried. And then I have some warmed up water. I actually had heated up too much, it was almost boiling, so I made sure to let it cool to a warm temperature. And then I'm adding the yeast to the water, and then I'll just be mixing it up. And this is just going to help with when we're adding our yeast into our hydrogen peroxide. Okay, we have our yeast all mixed up, and then we're going to add it to our hydrogen peroxide, and as you can see, the foaming and the decomposition of the hydrogen peroxide is pretty quick, and we could feel the heat coming from this reaction. Okay, so just to wrap up my presentation, I'm just going to dive a little bit deeper into what is going on with our hydrogen peroxide and our yeast and the chemical reaction that's occurring. So our hydrogen peroxide has a chemical formula of H2O2. It's a common antiseptic and is relatively unstable when it's exposed to light, which explains why it's stored in those dark brown containers when used for at-home antiseptic reasons. So when it is exposed to light, it actually decomposes into O2 gas, or oxygen gas, and then water, H2O. And while it's doing all of this, it is also exothermic and generating heat, which, as you can see, as I mentioned, that's why we were like putting our hands over the toothpaste just to feel the heat that's being released into the surroundings. So in the experiment, we introduced a catalyst to help encourage this reaction and help it occur more quickly, which is exactly what catalysts do. Our catalyst used was yeast, which contains an enzyme that's called catalase, which is, to be more exact, the catalyst of this reaction. So catalase can actually be found in living cells, in which it protects them from any oxidative damage, or in other words, any damage to the cells or molecules from oxidative compounds. So this damage can actually occur from reactions that are naturally happening in our body and have a byproduct of hydrogen peroxide. So to prevent this damage, The catalase enzyme helps break down hydrogen peroxide into the water and the oxygen gas that can be seen in our elephant toothpaste. And that pretty much wraps up my presentation on elephant toothpaste. Thanks for watching.